Right, here's some examples of how to do electrolytic cell questions. This is on page 15 of your notes. Okay, and so these are also out of your textbook, so if you have any questions, you can watch this video or else refer to your textbook for these examples. So we have electrolytic cell containing cobalt 2 chloride solution and lead electrodes is assembled. Okay, the notation for this cell is as follows. You'll notice because like our electrolyte is all in one container, we don't have the double lines in the middle splitting up our containers. We just have both electrolytes in one thing. Okay, and so we want to predict what reactions are happening at the anode and cathode and the overall cell, like the reaction that's happening overall in the cell, and then we want to draw a diagram of our electrolytic cell. Okay, and so we want to start labeling these as oxidizing and reducing agents, again looking in our formula sheet. So lead is a reducing agent, so they're both reducing agent. It really doesn't matter which one's which. Okay, and then chlorine's a reducing agent and cobalt's an oxidizing agent. So again, just looking at our data booklet on page 7, we can see those. Okay, now we find our strongest. We only have one oxidizing agent. Again, that's cobalt 2 plus. So we'll write out, I'm going to write it up here. So cobalt 2 plus 2 electrons produces cobalt solid. Okay. This again happens at our cathode. Okay, our strongest oxidizing reagent always is our cathode. Okay, and then at our anode, we're going to have our lead solid. It's going to break into lead 2 plus and 2 electrons. So that's at our anode. And now for our net, put them together. Okay, we have a 2 electron transfer, so we don't have to do anything there. So we just have cobalt 2 plus lead solid. It's going to produce lead 2 plus and cobalt solid. That's our net equation. So that's what's happening. That's the reaction that's going on while this electrolytic cell is connected. So now to draw the diagram. So again, for these ones, we're just going to have one container instead of two. Okay, we still have our 2 electrodes. So our 2 solids. Okay, in this case, they're both metal, or they're both lead solid. Okay, and then in our electrolyte, we have cobalt 2 plus and chloride. Now, some other things we want to make sure to include. So it says make sure you include the power supply. And so the power supply, so if we, let's say this is our anode, which now is positive. Okay, then this would be our cathode, which is negative. Okay, so those switch. Okay, we have our power supply. Okay, and the electrons are going to this power supply. Out, they still go from the anode to the cathode, so they're still going in this direction. Okay, so this is positive, this would be negative. And then we want to show like where our electrolytes are going. Okay, so our cations go towards our cathode and our anions towards our anode. And then the last thing we want to do is find the minimum voltage that must be applied to make the cell work. So again, our formula, our voltage, or like electron or electrode potential for a cell is half cell at a cathode minus our half solid our anode. We get these numbers out of our data booklet. So we get negative 0.28 volts minus negative 0.13 volts. And so our cell potential, minimum voltage, is negative 0.15 volts. So again, they should be negative for electrolytic cells, okay, showing that like we need this power supply to actually make these electrons move. Okay, the next example, the electrolytic cell is set up with a power supply connecting two nickel electrodes, and it's immersed in aqueous solution containing cadmium nitrate and zinc nitrate. Predict the equations for the initial reaction at each electrode and the net cell reaction. Calculate the minimum voltage that must be applied to make this occur. So we don't have to draw it out like this one. Okay, we just need to kind of predict the reactions, okay, and then find our voltage. Okay, so we need to again start. What do we have in here? So we have two nickel electrodes. So again, electrode means it's a solid. So we have solid nickel. We have, it's an aqueous solution. So we have water. Okay, then we have two aqueous solutions. So cadmium nitrate. So cadmium Cd2 plus, nitrate NO3 minus. It doesn't say anything about being acidic, so we don't have to add the H plus. We have zinc nitrate, so zinc is 2 plus, and we already have the nitrate. We don't need to write it again. Okay, so these are all our entities that we have in this solution. Now we need to label them. Oxidizing and reducing agent, so nickel is a reducing agent. Water can be both. Cadmium is an oxidizing agent. Nitrate on its own, I don't believe is anything. It needs to have H plus to be an oxidizing agent. Okay, and then zinc on its own is an oxidizing agent. Okay, a really weak one. Okay, so now we look through what's our strongest oxidizing or reducing agent, and strongest oxidizing agent is the nickel solid and cadmium 2 plus. Okay, so now we know our, so at our cathode, okay, is going to be our strongest oxidizing agent reaction, so Cd2 plus 2 electrons, and that's going to produce Cd solid. And then at our anode, we have nickel solid. That's going to produce nickel 2 plus and 2 electrons. Okay, again, we have a 2 electron transfer, so we don't have to times anything by any factors. And then so our net, put it together, so Cd2 plus nickel solid. It's going to produce nickel 2 plus and cadmium solid. That's our overall reaction. And again, like we can write it here, our numbers, so negative 0.40 volts. This is negative 0.26. And so again, if you write it down like cathode first, it's always cathode minus anode. So we get our minimum voltage is negative 0.14 volts. Okay, or you can write it out like this, showing like the reaction, whichever way works easiest for you.